So for our topic for today is all about additional topics on differential equation of the first order, specifically determination of integrating factor. So for example, we have a function. So we have a function m function of x comma y dx plus n function of x comma y dy is equals to 0. So suppose that, so this should be dy. So in case 1, suppose that we take the partial derivative of m with respect to y. So in our case 1, taking the partial derivative of m with respect to y minus partial derivative of n with respect to x, and then dividing that result into n, and when it gives us the function f of x, so we will use the integrating factor, this. So we will use this integrating factor, v is equals to e exponential of f of x dx. While on case 2, so this one, when we take the partial derivative of n with respect to y, and then we subtracted minus n, partial derivative of n with respect to x, and dividing the result with the function m, and when we have a result of g of y, we will use the integrating factor. So we will use this integrating factor, which is equivalent to v is equals to exponential of negative g of y dy. So, and after that, after getting the integrating factor, we will multiply our integrating factor into our function, which is this function, given function or our given problem. And then by multiplying that, so it will become an exact equation. So to see this determination of integrating factor, let's try example number 1. So in example number 1, we are given that 2y quantity x plus y plus 2 quantity dx plus quantity y squared minus x squared minus 4x minus 1 quantity dy is equals to 0. So the first thing that we're gonna do is we will distribute this on these terms. And then also, so now we will going to have 2xy, sorry. So this should be 2xy, and then plus 2y squared plus 4y quantity dx plus quantity, we will just copy these terms. So y squared minus x squared minus 4x minus 1 quantity dy is equals to 0. Now, let's take the partial derivative of this function. This is going to be our m, and this is going to be our n. So taking the partial derivative of m with respect to y, so we're going to have 2x plus 4y plus 4, and then taking the partial derivative of n with respect to x, so we're going to have, so this one, y squared will become 0, and then we're going to have negative 2x minus 4, then the partial derivative of a constant is just of 0. So now we're doing partial derivative of m with respect to y minus partial derivative of n with respect to x. So we will subtract this terms. So we're going to have 2x plus 4y plus 4 minus quantity negative 2x minus 4. So this is going to be our partial derivative of m with respect to y minus partial derivative of n with respect to x. So we're going to have 2x plus 4y plus 4. So distributing negative, so we're going to have plus 2x, and we're going to have plus 4. So simplifying further, we're going to have 2x. So we're going to have 2x plus 4y plus, sorry, should be 4x. So 2x, we will combine. Then this 2. So we're going to have 4x plus 4y and then plus 8. And then factoring 4. So So this is going to be our partial derivative of m with respect to y minus partial derivative of n with respect to x. So factoring 4, so we're going to have 4 quantity x plus y plus 2. So we notice that if we divide this equation, our result, if we divide this result to this x plus y plus 2, so x plus y plus 2 will cancel out. So if we divide this one by 2y, quantity x plus y plus 2, so this one will cancel out, 4, then 2. So this is going to be our 2 over y. This is going to be our partial derivative of m with respect to y minus partial derivative of n with respect to x multiplied by 1 over, what's that? 1 over m. So our integrating factor will become v is equals to exponential of negative integral of g of y. So we're going to have v is equal to exponential of negative integral of 2y dy. So this should be dy. So now let's go to next page. Don't have a space anymore. So, so our integrating factor is equivalent to exponential of negative gy, which is equivalent to negative 2 over y dy. So integrating that, we're going to have exponential of negative 2 ln y. And then, we're going to have integrating factor as y raised to negative 2. And then, the next step that we're going to do is we will multiply this one into our given problem. So our given problem is, so we multiply by y raised to negative 2 quantity, apologies. So we're going to have quantity 2xy. So this is our problem, plus 2y squared plus 4y quantity dx plus quantity y squared minus x squared minus 4x minus 1 quantity dy is equals to 0. So multiplying this, so we're going to have 2x, that's going to be y raised to negative 1 plus 2, so plus 4 y raised to negative 1 again, then it's going to be our dx multiplied by dx plus distributing this one on these terms. So we're going to have 1 minus x squared y raised to negative 2 minus 4x y raised to negative 2 and then minus y raised to negative 2 dy is equals to 0. And then, checking for exactness, so we will now take the partial derivatives. So we're going to have, again, so partial derivative of m with respect to y. So we're going to have negative 2xy raised to negative 2. And then plus, this should be minus. So this one, so minus 4 raised to times y raised to negative 2. And then taking the partial derivative of n with respect to, what's that? With respect to x, we're going to have, so 1 is just a constant, so it will become 0. So we're going to have negative 2x y raised to negative 2. And then, minus 4y raised to negative 2. As you can see, partial derivative of m with respect to y is equal to partial derivative of n with respect to x. So we can therefore conclude that this is an exact. equation. And then, we will do the same thing that we did on our first order differential equation topic. So, we're going to have, I'll just rewrite our problem again. So, we're going to have 2xy raised to negative 1 plus 2 plus 4y raised to negative 1. So, that's dx. And then plus quantity of 1 minus x squared y raised to negative 2 minus 4xy raised to negative 2 and then minus y raised to negative 2 dy is equals to 0. So integrating this one where y is equals to constant and then integrating this side where y where pure y only will only be integrated. So this one will become 0. This one is also become 0. So now let's now integrate. So we're going to have 2x squared over 2 and then y raised to negative 1 plus 2x plus 4x y raised to negative 1 plus, so in here we're going to have y and then y plus y raised to negative 1. Am I correct? Plus y raised to negative 1 is equals to c. Then as you can see, this one will cancel out. So we're going to have x squared y raised to negative 1 plus 2x plus 4x y raised to negative 1 plus y plus y raised to negative 1 is equals to c. So simplifying further, we're going to have x squared and then plus 2xy plus 4x plus y squared plus 1 is equal to cy. So that's the answer. So now let's try our second example. So our second example is we are given that y quantity 4x plus y quantity dx minus 2 quantity x squared minus y dy is equals to 0. So the first thing we should do is distribute all the terms. So we're going to have 4xy plus y squared quantity dx plus, we're going to distribute this. So it's going to be negative 2x squared plus 2y dy is equals to 0. And then the next step is we will now take the partial derivatives. So the partial derivative of m with respect to y is equal to, so we're going to have 4x plus 2y. Then taking the partial derivative of n. By the way, this is our m and this is our n. So partial derivative of n with respect to x. So we're going to have negative 4x, and then so 2y will become 0. As you can see, the next step is this partial derivative of n with respect to y minus partial derivative of n with respect to x. By doing that, we're going to have so is equal to 4x plus 2y minus quantity negative 4x. So it turns out we're having 4x plus 2y plus 4x, distributing negative sign. So simplifying further, we're going to have 8x plus 2y. So you can see if I factor 2, we're going to have 2 quantity 4x plus y. And if I divide this one, by this. So by this, which is our m, we're going to have g of y. So by doing that, we're going to have partial derivative of m with respect to y minus partial derivative of n with respect to x multiplied by 1 over m. So we're going to have 2 quantity 4x plus y and then multiply by, divided by m. So our m is y quantity 4x plus y. So 4x plus y will cancel out. So we're going to have 2 over y. So this is going to be g of y because we have a function y here. And then, moving forward, so we're going to have our integrating factor. So our integrating factor will be equal to exponential of integral of negative g of y. Ano? Negative g of y dy. So this is equivalent to exponential of negative integral of, what's that? Negative 2 over y dy. Then integrating that, we're going to have our integrating factor. So this will become exponential of negative ln, negative 2 ln y. So this will become exponential of ln y raised to negative 2. So you can see exponential and then the ln function will cancel out. So we're going to have our integrating factor, y raised to negative 2. We will multiply this to our given problem. So we're going to have y raised to negative 2 quantity. So 4x y and then plus y squared dx. So this is our problem. Negative 2x squared plus 2y dy quantity is equals to 0. Okay. Is equals to 0. So multiplying this onto these terms, we're going to have 4x y raised to negative 1 plus 1 quantity dx plus quantity negative 2x squared y raised to negative 2 plus 2 y raised to negative 1 dy is equal to 0. Now, checking for exactness. So, let's test for exactness. Test for exactness. So, we will now take the partial derivative again. So, we're going to have partial derivative of m with respect to y. So, we're going to have negative 4xy raised to negative 2. Then plus 1 will become 0. So, taking the partial derivative of n with respect to x, going to have negative 4x y raised to negative 2. You can see that our partial derivatives are the same. So we can therefore conclude that this is an exact equation. So next is, we're going to now integrate our equation. So let's do it here. So we're going to have quantity for x y raised to negative 1 plus 1 dx plus quantity negative 2x squared y raised to negative 2 plus 2 y raised to negative 1 dy is equal to 0. So integrating the first term where y is equals to constant, then integrating this side where pure y is only to be integrated. So as you can see, this one will become 0, this term. So we're going to have, let's now integrate. So we're going to have 4 x squared over 2y raised to negative 1 plus x plus, as you can see, this is equivalent to 1 over y dy. So the integral of that is equal to ln of y. So we're going to have plus 2 ln of y is equal to c. And then this one, further simplifying our solution, so 4 and 2 will cancel out. So we're going to have 2x squared over y plus x plus 2 ln of y is equals to c. Multiplying both sides of the equation by y, it turns out our equation is 2x squared plus xy plus 2y ln of y is equals to cy. So that's the answer. See you on my next video.